Okay, in the previous class we had studied about rupture strength. So now let us know about block shear and design of block shear. The block shear formula, it is TDB equals AVG into Fy divided by square root of 3 into gamma m naught plus 0.9 to ATN into FUP by gamma m1. So this formula, it is there in page number 33, the code book IS 800 2007. Okay. So coming to this, just check out this, it is there in the code book also, page number 33. So this is okay. Look at here, you have a formula over here. So bolted connection, so block shear strength of TDB connection shall be taken as TDB equals AGFI by square root of 3 gamma m naught. So in this you have an all your, even your rupture strength formula also you have here, that is page number 32, and whereas your block shear, it is in the page number 33. So by using that formula, so here AVG, it is an unknown factor, you need to calculate it. Fy, it is known already, and gamma m naught, it is known factor, and whereas ATN, it is also an unknown factor, and FUP and gamma m1, it is known factor. So coming to this LV, it is 70. Why it is LV is used? Because the AVG formula, it is here LV into T. So T is thickness of your angle, and whereas LV, it is 70. How does it 70? It is from here. So this is LV from this to this. This is pitch distance 40 and the edge distance, it is 30. So total together 40 plus 30, it is 70. So from this edge to this center of next bolt. Okay, so total together it is 70 mm. So that we call it as that we know that LV is 70 mm. LC, it is nothing but pitch distance. So pitch distance, this is the pitch distance, we call it as LC. So that is 40 mm. And whereas LT, how do it is LT? It is from this W1 value. This is W1 value for particular angle for 50 by 50 by 6. This W1 value, you get it as 28 mm. Okay, so after this so the total together it is 50 mm. Now 50 by 50 by 6, right? So this breadth is 50, so 50 minus 28, it is 22. So that is nothing but your LT value. So LT is 22 mm, and D naught, D is 16 and the cover is 2 mm, so that is D naught. So 18 mm is there. So coming to calculate the AVG. AVG formula is LV into T. LV is known factor, that is 70 mm, and T is thickness. So how do you know that thickness? Thickness, you know this angle, length into breadth into thickness, right? So thickness is T is 6 mm. So 6 mm is there. So after calculating this, AVG will be 420 mm square. So coming to this AVN. AVN is nothing but AVG minus 1.5 times of D naught into T. This is standard. Okay, 1.5 D naught into T is there. No, this 1.5, it depends on number of bolts which you have it. Okay, this bolts. Okay, there are 2 bolts. That's the reason you have taken this as a 1.5. Okay, so in future I'll tell that what it is. AVN equals AVG is known 420 and 1.5, D naught is 18 and T is 6 mm. So your AVN value is 258 mm square. Whereas your ATG is LT into T. LT is known already, I've told you in the earlier. So that is 22 and the 6 is thickness. So your ATG value is 132 mm square. So coming to this ATN is equals ATG minus 0.5 times of D naught T. Actually remember this is standard. This ATN, what you are seeing this formula na, ATG minus 0.5 times of D naught into T. What is 0.5? I'll tell you. Here 1.5 what you have taken now. So 1.5 actually out of 2 number of bolts. So it here 0.5 plus 1.5. Total together it is 2 number of bolts are there. So 0.5 D naught into T, your ATN value is 78 mm square. In case if you have a 3 number of bolts, what will be there? So this is standard will be there. ATN will be standard, that is ATG minus 0.5 times of D naught T. And here this 1.5 becomes 2.5. Okay, 2.5 plus 0.5, so that will be a 3 number of bolts. In case if you have like, in case 4 number of bolts is there, so that time that becomes AVN becomes AVG minus 3.5 times of D0 into this will be standard. So, so 4 number of bolts ಇದೆ ಅಂತ ಅಂದರೆ 4 minus 0.5 whatever it will be there. So, that will be your one AVN values. Okay. So, entire value is substitute here. So, again TDB substitute to your formula for this formula, and here I have multiplied by 2 because it is double sided angle. Okay. So, for that reason I multiplied by 2. When you multiply that 2, after substituting that you will get your value, that is 73.97 kilonewton, and the block shear value is 73.97. This is the greater than factor load. Okay. Hence the design block shear is safe. Nima factored load, check out your factored load. So, so for that it is the factored load was how much actually. Yeah, we'll check out.